So, good evening everyone. This is the continuation of the chapter 4. I am Rosemary Kabukayan and my topic is all about the loon masking, the types of intelligent storage system, high-end storage system, mid-range storage system, concept and practice of the EMC, Symmetrics, and VNX, the EMC Symmetric Storage Array, EMC Symmetrics VMAX component, and the Symmetrics VMAX architecture. So in 4.2.3, we have the loon masking. Loon, or the logical unit number masking, it is a process that provides data access control by defining which loon a host can access. So loon masking is mura siya og divider that ang isa ka department, for example, a sales department and a finance department. So the sales department can only access the data of the sales, while on the other hand, the finance department can also access data of the finance department only. So that is loon masking. So loon masking function is implemented on the storage array. So this ensures the volumes accessed by a host is controlled appropriately, preventing unauthorized or accidents used in shared environments. So loon masking, it ensures that the data are secured and those unauthorized persons or hosts cannot access those informations that are not available for them. With loon masking, LUN are accessible to the designated host. So as I've said, so if you're under sales department, you can only access sales department LUN or those data under the sales department only. The next topic we have is 4.3 types of intelligent storage systems. So we have two, the high-end storage system and the mid-range storage system. So first, what is high-end storage system? So high-end storage system, it is referred also to as active arrays, are generally aimed at large enterprises applications. So these systems are designed with a large number of controllers and cache memory. So an active array implies that the host can perform IOS to its LUNs through any of the available controllers. So we have a figure here. Wait. As you can see, so this is the figure of the high-end storage system. Then, high-end storage system provides these following capabilities. So these are the advantages of the high-end storage system. The first one is large capacity storage. As I've said ganina sa iyahang definition, so high-end storage system generally aimed at a large enterprise application. So it must be dako siya og storage capacity. The second one is large amount of cache to service, host, or IOS optimally. Fault tolerance architecture to improve data availability, connectivity to mainframe computers, and open system host. Availability of multiple front-end ports and interface protocols to serve a large number of hosts. Then also, we have availability of multiple backend controllers to manage disk processing, scalability to support increased connectivity, performance, and storage capacity requirements. Second to the last one is the ability to handle large amount of concurrent IOS from the number of hosts and applications. And also its support for array-based local and remote data replication. So that is the capabilities of the high-end storage system. Now we will move on the mid-range storage system. So mid-range storage system, also referred to as active-passive arrays. So kung ang high-end is active-active, the mid-range is the active-passive arrays. So mid-range storage system is suitable for small and medium enterprises applications. So mid-range storage system provides optimal storage solutions at lower cost. In an active-passive array, a host can perform IOS to a LUN through the controller that owns the LUN. So, given here is the figure of mid-range storage system. So, mid-range storage systems are typically designed with two controllers, each of which contains a host interfaces, cache, RAID controllers, and interface to disk drive. Mid-range arrays are designed to meet the requirements of small and medium enterprises applications. Therefore, they host a less storage capacity and cache than high-end storage systems. So, mas gamay ra og capacity si mid-range compared to high-end storage system. There are also fewer front-end ports for connections host, unlike sa high-end kadaghan siya og front-end ports. However, they ensure high redundancy and high performance for applications with predictable workloads. They also support array-based locals and remote replications. Now, let's move forward to the next topic. Under 4.4, the concept in practice, EMC, Symmetrics, and VNX. So, the EMC symmetric storage array is an active-active array implementation. Symmetrics is a solution for customers who require an uncompromising levels of service, performance, and the most advanced business continuity solution to support large and unpredictable application workloads. So, Symmetrics also provide built-in advanced level security features and offers the most efficient use of power and cooling to support enterprise level data storage requirements. The EMC VNX storage array is an active-passive array implementation. So EMC Symmetrics and VNX is different. So when we say EMC Symmetrics, this is active-active array just like the high-end, and the VNX is like the mid-range storage system, which is active-passive. So it is EMC's mid-range storage offering is an active-passive rate. It is EMC mid-range storage offering that delivers enterprise quality features and functionalities. The EMC VNX is an unified storage platform that offers storage for block, file, object-based data within the same array. So it is suited for application that is with predictable workloads that required moderate to high throughput. Details of the unified storage and the EMC VNX are covered in the chapter 8. Next, under 4.4.1, we have the EMC Symmetric Storage Array. So the EMC Symmetric establishes the highest standard and performance capacity for an enterprise information storage solution and is recognized as the industry's most trusted storage platforms. Symmetrics. Okay, so when we say EMC Symmetric Storage Array, so Symmetric offers the highest level of scalability and performance to meet even unpredicted I/O workload requirements. So the EMC Symmetrics offering includes the Symmetrics Virtual Matrix, that is the VMAX series. So the Vmax is the virtual matrix, symmetric virtual matrix Vmax series. The EMC symmetric Vmax So the EMC Symmetric Vmax series is an innovation platform built around the scalable virtual matrix architecture to support the future storage growth and demands of the virtual IT environment. So we have here the key features supported by the Symmetrix Vmax. So number one is incrementally scalable up to 2400 disks. The second one, it support up to 8 Vmax engines. Third, support flash drives, fully automated storage steering, or the fast virtual provisioning and cloud computing. The fourth one is to support up to 1 TB of global cache memory. Fifth, support FC, ISCSI, Gig, and FACON for host connectivity. The sixth one, support rate levels 1, 1 plus 0, 5, and number 7, it supports storage-based replication through EMC Time Finder and EMC SRD. The last one is highly fault-tolerant design that allows non-disruptive upgrades and full component-level redundancy with hot swappable replacement. So that is all about the EMC Symmetric Storage Array. Now let's move forward to the 4.4.2, which is the EMC Symmetric Vmax components. So these are the components of the Symmetric Vmax. So the first one is the Vmax engine. So what is the Vmax engine? So the Vmax engine consists of a pair of directors that contains 4 quad-core Intel processors up to 128 GB of memory and up to 16 front-end ports for host access or SRDF channels. So that is the Vmax engine. The second component is the Matrix Interface Board Enclosure, or the MIB. So the Matrix interface board enclosure, so it contains 2 independent matrix switches that provide point-to-point communication between the directors. So each directors has these 2 connections to the Vmax matrix interface board enclosure, because every director has 2 separate physical paths to every other directors via the virtual matrix. So this is highly available interconnect with no single point of failure. So these designs eliminates the needs for separate interconnects for data control, messaging, and environment and system test. So a single highly available interconnect suffices for all communications between the directors, which reduces the complexity. The fourth one is the service processor. So when we say service processor, this is used for system configurations and the management console. So service processor provides notifications and support capabilities to allow access to the system locally or remotely. So the service processor automatically notifies the vendor's customer support center whenever a component failure or an environment violation is detected. The last component we have is the Symmetrix Ingenuity, if I'm reading it right. So when we say Symmetrix Ingenuity, the operating environment for EMC Symmetrix Ingenuity manages and ensures the optimal flow and integrity of the information through the various hardware components of the Symmetrix system. So the Symmetrix Ingenuity manages all the Symmetrix operations and system resources to optimize performance intelligently. Invinity ensures systems availability through advanced fault monitoring, detection and correction capabilities, and also it provides current maintenance and service features. So it offers foundations for specific software features and for disaster recovery, for business continuations, and for storage management. So that is the four EMC Symmetrics VMAX components. Now let's move on to the last topic, which is under 4.4.3, the Symmetrics VMAX architecture. So each VMAX engine contains a portion of global memory and two directors capable of managing the front end, the back end, and the remote connections simultaneously. The VMAX engines is connected to the virtual matrix, and it allows all system resources, including the CPU, the memory, the drives, the host ports, to be dynamically accessed and shared by any host. Additionally, VMAX engines can be added non-disruptively to efficiently scale system resources. So the virtual matrix or the VMAX supported up to 8 VMAX engines in a system, which is shown in the figure. Here we have the figure 4.13 4-13, which is the VMAX architecture. So to sum it up all, for the chapter 4, so this chapter details the features and key components of the modern intelligent storage systems. So it includes the different types of storage systems, which is the high-end and the mid-range, and their characteristics were also explained. An intelligent storage system provides the following benefits to an organization. So first we have is it increases storage capacity. So especially when you're using the high end, kay dako-dako siya og capacity, unlike sa mid-range. So also it improves the I/O performance, easier storage management. It also improves data availability since daghan man ang mga store niya nga data. Improves scalability and flexibility. Also, it improves business continuations and improves security and access control. So, an intelligent storage system is an integral part of every data center. So, the large capacity and the high performance supported by the intelligent storage system makes it necessary to share among multiple hosts. So, daghan ang makagamit sa data, especially if dako ang ma-store niya nga data for a business. Or intelligent storage systems enable enterprises to share data easily and securely. So mas dali ka maka-share sa imong data, secured sa imong data. So storage networking is a flexible information-centric strategy that extends the reach of intelligent storage system through an enterprise. It provides a common way to manage, share, protect enterprise information assets. Storage networking is detailed in the next chapter of the book. So that ends the chapter 4, and this also ends my design topic. Thank you for listening, and God bless.